right, so good afternoon or good morning, everyone. Welcome to the first invitation-only Opentrons Flex live demo. My name is John Martinez. I am the Senior Director of Sales here at Opentrons, and I'm going to be joined by my colleague, Nick Diehl, who's part of our application sciences team. The focus of today's session is to provide you all with an overview of Opentrons' new next generation robot, the Opentrons Flex. I'll start by explaining some key features, and then we'll run through a short demo and finally answer any questions you might have. So I'm going to pause here for a minute just to make sure everyone who signed up can join. And I just want to use this time to plug our new demo room, which is where this webinar is taking place. This demo room just opened up in our headquarters, which is in Long Island City, New York. If you or anyone from your team are based out of the area or visiting New York City or the tri-state area, feel free to work with your main point of contact at Opentrons to schedule some time to come and visit us, check out our office and lab, and see the Opentrons Flex in person. So I'm just going to give it a minute so that everyone can get in. Another quick note, we are in kind of a normal lab space. So we've got some heavy duty freezers here that are running. So if you hear any kind of whirring in the background, that's what it is. Oh. All right, looks like we're good to get started. So just a quick reminder to everyone that this webinar is being recorded and it will be made available on the Opentrons website. We'll also be sending a copy of the recording via email to all of you within 48 hours. And to help with the overall experience, everyone is on mute. To ask questions, please use the Q&A box on your screen and we'll answer these at a few key points in the talk. So let's kick it off. First, I just want to say a few things about Opentrons' ethos and why we exist and what our mission is. So we are really focused on supporting scientists doing groundbreaking, valuable research by providing them with powerful, accessible lab automation that frees you to do more than pipette. We've helped thousands of labs all across the world with the OT2, and the Opentrons Flex, which is our next generation robot, is a more powerful but just as accessible tool as the OT2. I'm excited to show you how it can help you in your lab, increase your throughput, and automate more. So I'm going to start off by showing a few key features of the Flex, and then Nick is going to run through a short demo so you can actually see it in action. We'll pause to take questions as we go, so please remember to type them into the Q&A box, really whenever a question pops up. So as you can see next to me, this is the Opentrons Flex. It's larger than the OT2, and it's roughly a 3-foot cube, but still fits nicely on a lab bench, taking up about 2/3 of a bench. Right over here in the back is the gantry, which we're going to see moving during the demo. And if you're not familiar with the gantry, it's a fancy word for the Z-axis of the robot. The gantry holds 1 or 2 pipettes and also holds a gripper regardless of how many pipettes are on it. So this is a pipetting robot. Let's talk about the pipettes. The pipettes available are single channel, 8 channel, and 96 channel. The single channel and 8 channel come in 2 sizes. The P50, which covers 1 microliter to 50 microliters, and P1000, which covers 5 to 1000 microliters. The 96 channel comes in only 1 size, which covers 5 microliters to 1000 microliters. These are really wide volume ranges that offer a lot of flexibility for a lot of applications that require different volumes. One that comes to mind is nucleic acid extraction. Pipettes with wide volume ranges are valuable for users because they make it really easy to swap between significantly different volume ranges without needing to swap pipettes. It lets you do more with less, essentially. You can hold any combination of single and 8 channel pipettes on the gantry at once. That can be 2 singles, 2 multis, 1 single and 1 multi, or just the 96 channel alone because of the size of that pipette. So right over here to the right, which again, you'll see in a bit, is the gripper. This sits to the right of the pipettes and can move tip racks or plates across the deck or into the trash bin at the back. We'll also have a trash chute available, which will sit on the front of the deck and attach to an external bin so that when you're running high throughput workflows, you can restock the deck with new tips or plates. This really extends the walkaway time you can achieve with a benchtop robot like ours. We can actually achieve 96 sample throughput for complex protocols like NGS library prep using the gripper, 96 channel, and modules available. The deck that you're seeing right over here features 12 standard slots where tips, labware, and modules would be placed. We'll also have 4 extension deck slots available, and those will sit to the right of the main deck, right over here in this space, and can be used to hold extra tips or labware. The gripper can, of course, access the 12 standard slots, but can also access the 4 extension slots, which allows you to bring additional labware onto the main deck so that the pipettes can access them. We offer a wide range of modules that are fully compatible with the Flex and the entire Opentrons software ecosystem, and there are 4 that I want to mention today. We have a thermocycler, which has automatic opening and closing capabilities, a magnetic block, which is an industry standard 96 well magnet plate, a temperature module, which has a range of 4 to 95 degrees Celsius, and a heater shaker, which can go from 200 to 3000 RPM. With these, you can automate a really wide range of molecular biology, cell biology, and related applications. And they're called modules specifically because everything is modular. This means that you're not tied to one application forever, and you can easily swap or upgrade your hardware to change the application or increase your throughput. Over here, you'll see an on-deck display touchscreen. This allows you to easily store, pull up, and run protocols. It also guides you through deck setup and automated calibration, which Nick is going to run through in greater detail shortly. Most importantly, the touchscreen provides a lot of prompts and a lot of guidance. So it really makes the manual steps that you go through before the robot starts to run really straightforward and really easy for anyone in the lab to carry out, whether they have experience with automation, experience with Opentrons products, or no experience with automation whatsoever. Unfortunately, you won't be able to see a crisp view of the touchscreen in this webinar, but we do have a software webinar next week on July 19th that will show this in much more detail. So I'm going to pause now and see if there are any questions before Nick runs us through the protocol. And I'm joined by our Senior Director of Strategic Marketing, Fran Slater, who's going to be the Q&A moderator. So Fran, any questions?
Hi, John. We've got a couple of questions, one of which I'm going to leave till the end because I think it would be a good thing for Nick to touch on. But the one that we can do now is how is the Flex different to the OT2?
Yeah, that's a good question. We've obviously been getting that question a lot. So I think overarchingly, the OT2 is really a low to medium throughput and low to medium complexity machine. The Opentrons Flex is really medium to high throughput and medium to high complexity. I would say this is primarily driven by the additions of a gripper and a 96 channel, which just allow for a lot less manual intervention, more walkaway time, higher sample count, all that good stuff. I would say that the combination also of the automated calibration and the on-deck touchscreen just provide a really seamless experience for the user. And these are all significant upgrades from the OT2 that allow that higher throughput, higher complexity workflow. So now I'm going to pass it off to my colleague, Nick Diehl, and he's going to run you guys through a demo.
Hi, everyone. Thanks so much, John. So my name is Nick from the Opentrons Application Sciences team, and I'll be walking through a demo protocol on the Flex, and then discussing in a bit more detail the modularity of the system and run through calibration at the end before we take some questions. So once you have your robot, you might be wondering, how do I get a protocol to run my Opentrons Flex robot? We have a few options, the first bucket of which is self-service. And within that, we have our Python API, which is fully documented and open source. So if you'd like to try your hand at coding your own protocol, you're always welcome to try that out. We also have a protocol designer graphical user interface, which is a very easy drag and drop method to create lighter weight, simpler protocols for non-technical users. And lastly, we have our protocol library, which is a full repository of hundreds of protocols that have been written for other users, some of which have even been validated in-house or by third-party partners. And you can download those for free and run them at any time. The last option that we have is remote protocol development services or on-site protocol development services from an expert on our team to do for you. So once you have your protocol, you'll want to first open your Opentrons desktop application for the first sending of the protocol to the robot. From there, as John mentioned, the protocol will be stored and available for future use right on the on-device display. So I'm going to open up my Opentrons application here. I'll import my file from one of the methods that I just discussed. And once the protocol simulates on your computer, you can start the setup on your Opentrons Flex robot. If anyone's done this with an OT2, it's the exact same process as the OT2. Once we get over to our on-device display here, you'll be prompted with your protocol setup screen. And here we'll be notified of all the different instruments, modules, and labware that we'll need to run the protocol. So up top, I know it's a bit difficult to see, but we have our instruments and modules section. This will ensure that the physical equipment that we need is attached to the robot. Instruments will contain anything from our pipettes to our gripper, and our modules will be any of the modules that John mentioned in his talk. We can also see our labware tab here, which will allow us to view a map visualization of where our labware needs to go on the deck so that we can physically make sure that the physical labware is placed where the protocol requires it in the software. So if I navigate to that labware section, I'd see that I need to move my plate over to slot 2. And at this point, my physical layout matches my protocol requirements, and I'm ready to actually start the protocol. And from here, it's as simple as selecting the play button on the protocol screen. You'll see that our screen now changes to an X and a pause, which will allow us to manually pause or cancel the run at any point if we need to. The first step of this demo protocol will show off our single channel pipette for some features that might be common, such as cherry picking from wells dispersed from a parent plate to a new plate on our heater shaker module in this case. So we're reformatting some wells from our source plate into our heater shaker plate. At this point, we'll show off the functionality of our multi-channel pipette, in this case, our 8-channel P50 pipette. This will accommodate a range of 1 to 50 microliters. So in this case, we're picking up our 8 tips at the same time, and we'll move over to our reagent reservoir. Aspirate a large volume of liquid. And move over to our destination plate for a multi-dispense. So in other words, we're distributing using one aspiration for multiple dispenses into our well plate. At this point, you'll notice that the latches of our heater shaker module will automatically close and prepare the heater shaker module for heating and shaking. We can shake up to 3,000 RPM, and we can heat up to a temperature of 95 degrees Celsius. Once the shaking cycle is complete, the labware latch can open and make the plate accessible for our gripper to come and move it onto our magnetic block. The gripper features pressure sensors to ensure that the plate is accurately picked up and dropped into its destination. Our magnetic block features 96 individual circular magnets, which can pull beads away from sample. At this point, we can pipette directly into our thermocycler module. I'd also like to point out that on the on-device display, if you swipe over to the right during a run, you'll be able to visualize a more detailed readout of all the steps of your protocol. We'll perform our last transfer to the thermocycler. I'd like to point out as well that the block and lid of the thermocycler have independently controlled temperatures, which can ramp from up to 105 degrees Celsius on the lid and 95 degrees Celsius on the block. The thermocycler can also automatically close and open the lid for cycling profiles or pipetting into the module. And before that happens, the pipette will home to safely accommodate the closing of the lid. The module also features a mechanically engaged lid, which ensures accurate pressure on the plate seal, ensuring no evaporation occurs. There's also a manual release in the event that you'd like to manually open up the lid. So here we'll automatically open. And with that, our protocol will complete. And you'll see a nice readout in green, letting you know that your run completed successfully. Now that we've finished our protocol, I'd like to show you how easy it is to manipulate the deck and the instruments of the Opentrons Flex. So on the on-device display here, I'm just going to navigate to our Instruments tab. I'm going to select our left mount, and let's say that we'd like to detach our P1000 single channel pipette. I'll simply select Attach. I'll be notified that I require a 2.5 millimeter hex screwdriver, which ships with the robot. It also lets me know that I'll need to move the labware off of the working area of the deck, which in this case is slots 2 and 5. So I'm just going to replace my plates there and grab my driver. I'll select to move the gantry to the front of the robot. And I'm just going to slide over here to show you how easy it is to replace the pipette. So you'll notice there are 2 captive screws which hold the pipette in place and ensure accurate communication with the robot. And it's as simple as unscrewing these 2 vertical screws and popping the pipette out. And in a matter of seconds, we're ready to go to either attach a new pipette or continue on with a new protocol. I also wanted to highlight the modularity of the deck itself. So some labware and modules come right off the deck as is. They pop into these brackets, which hold the plates and other labware in place. So plates can come out quite easily. Our magnetic block sits in one of those as well. Our modules are slightly different in that they require the use of bespoke carriages to place them in place. So it's quite simple to replace the heater shaker in this case. I'm going to use a 3 millimeter wrench and simply pop out the 2 screws holding the slot and carriage in place. And once I physically remove the module from its position, you'll notice there are 2 connections, one of which is a USB connection, which allows the robot to speak with the module. And the other is the power source for the module. I'll place that to the side. And let's say I'd like to replace it with one of our standard deck slots for use with standard labware. I'll place the slot in and simply replace the 2 screws. And so you can really see how simple it is. Basically, the full modularity of our system can be accomplished with 2 screws in any situation. And with that, we're good to go. Lastly, before I welcome John back in, I'd like to show you how simple it is to calibrate pipettes automatically on our platform. So in this case, we still have our P50 multi-channel pipette, 8-channel pipette on the right mount. I'll select that pipette on our display here. I'll select recalibrate, and I'll be prompted that I need my calibration probe, which is conveniently accessible via magnet on the frame of the robot. I'll move the pipette to the front, again, ensuring that slots 2 and 5 are not occupied. And here there's a modal letting me know exactly what I need to do with the calibration probe. I'll place it on the backmost channel of our pipette, screw it in by hand, make sure it's tight, and select begin calibration. And with that, we can walk away knowing that the robot will access its capacitive sensing technology to align itself in the X, Y, and Z axes with up to 0.1 millimeter resolution to make sure our pipette is really finely accurate. And while this is running, I'd like to welcome back in John to take any questions that might be out there from the group. Thank you.
Great. Thanks a lot, Nick. So we're going to spend the rest of this webinar answering questions. So please ask away in the Q&A box and we'll let Fran moderate.
Okay, great. Yeah, so the Q&A box is open at the bottom of the screen. We've got a couple of questions, but please keep them coming in because we have plenty of time to answer them. Okay, so question number 1 from Agnes. How many protocols can the Flex have?
Yeah, really good question. So I don't have a specific number. I think the general answer is it has enough space to store essentially as many protocols as you'd ever want. It would be unreasonable to expect that you would exceed the storage limit that it would have. I don't know if Nick has any additional detail, but that's generally the answer.
Yeah, I will second that. The size of the protocol will vary from protocol to protocol, but generally we haven't ever hit a limit of storage capacity on the Flex.
Super. Okay, next question. Does it have liquid level detection?
Yes. So I'm going to give a basic starting answer and then I can pass it to Nick. This robot will have liquid level detection. So at launch, as in when we ship it, that will not be available. However, the sensors needed for liquid level detection are built into the pipettes. And so LLD is essentially just a software update that we'll be pushing later this year, most likely Q4, I believe. You will have the ability to enable or disable that. So it'll be quite flexible. Nick, I don't know if you have anything to add.
Yeah, I think you nailed it. The technology is built into the hardware, and so it will be a software update, as John mentioned. We can always use other methods of liquid level detention in the meantime, so we can calculate with pretty high degree of accuracy based on the geometry of the well, how far we need to track down the liquid, and a few other solutions. But for right now, liquid level detection will be a fast follow feature.
Excellent. So this is a question from Dina. What are the tolerances for the onboard pipettes at the high and low end of the pipetting range? And if you don't have that to hand, I do have it open, guys. If you want to pass it.
I do not, but I will pass it to Nick to see if he can answer.
Yeah, at the risk of giving the wrong answer, I'd rather have, if you don't mind, Fran, if you could just send out the documentation from testing that we have at this point. I know
Yeah.
Sure, yeah, I can give you
we
a
can
few.
follow.
Yeah, we can follow up. So I also have I have 1 microliter and 5 microliter specs in front of me. So accuracy is plus minus 8%, or inaccuracy, I should say. Imprecision is plus minus 5% at 1 microliter. And then at 5 microliters, sorry, that's for the 1 to 50 microliter channel pipette. And then for 5 microliters on the 5 to 1,000 pipette, inaccuracy is plus minus 5%, and imprecision is plus minus 2.5% at 5 microliters. You can also find those specs on the website. If you go to opentrons.com and navigate to the flex pipettes, or pipettes, as you say in America, the flex pipettes page, product page, you can see those specs and a few other specs as well.
Thanks, Fran.
Okay, great. So plenty of questions coming in. So we're just going to keep it rolling.
Sure.
Is there any detection of potential failure during the replacement of 96 well plates or tip racks with the gripper?
Go for it, Nick.
Yeah, happy to take that one. So there are pressure sensors in our gripper, which will let it know if a plate or rack has been successfully picked up. And so long story short, yes, there is an error thrown by default if the gripper does not detect that it's successfully picked up or placed down a piece of labware. We expect that to be configurable in the future, but for the time being, the default state is to throw an error, let the user know what happened, and exit the run.
Perfect. Okay, so next question from Samvitha. Can the flex add a seal to the plates, or will that have to be added manually?
My understanding is that that will need to be added manually. I don't believe that we have any piece of equipment that's capable of applying enough pressure at that wide of an area to apply a seal. I don't know if you have anything else.
That's all I have as well. I have seen some third-party applications of plate sealers on our OT2 in the past, and I'm happy to connect with you about specifics after the call.
Yeah, good plug for the open source nature of the Opentrons Flex, and really just Opentrons as a business. So, there are folks out there that we'd be open to potentially connecting you with, or, open to working with you on getting the right information on the hardware and software to be able to integrate something in yourself. But we have no off-the-shelf solution that can offer that.
Excellent. Okay, next question is from Chris. How often is recalibration required in a continual use? And there's a follow-up question. What happens if, for example, one barrel on an 8-channel on an 8-well multi-channel is out of spec versus its neighbors? So let's do the first question first, just to repeat it. How often is recalibration required if you're using the flex continuously?
Yeah, good question. So I think that there are two different definitions of recalibration that I would specify first. One is calibration from a volumetric standpoint of how much solution is being aspirated or dispensed according to what's supposed to be happening based on the pipette volume. That's kind of the industry standard definition. However, you might have heard Nick say calibration earlier when he talked about that little probe on the end of the pipette, which is essentially the geometric calibration, which is basically how does it know where to go correctly on the XYZ axis. So let's break it out into two different answers. On the XYZ axis, the calibration of the pipette or the pipettes only needs to happen when you attach the pipette. I think that there's probably an argument that if you're running the same protocol and never changing pipettes for a very long time, as in multiple months with extremely heavy usage, you're probably going to be benefiting by recalibrating the geometric calibration every, I don't know, couple of months, maybe. I mean, we haven't tested a specific number to say, hey, 3 months after using it every day, 8 hours a day, you should recalibrate. But we would expect that you should redo that geometric calibration. Again, just using the calibration probe and the on-deck display, if that's your usage. If that's not your usage, extremely infrequently. Every couple of quarters, I would say, based on how frequently it's being used. Or if you notice that something has happened and you just want to kind of really, really tightly make sure, you can always recalibrate just based on how easy the process is. On the volumetric, so real quick, Nick, do you agree with all that? On the volumetric calibration, any comments?
Yeah, absolutely. On the geometric calibration, I'm right there with you. Just want to point out again that the calibration is actually complete. So that's how quick and easy the calibration process is on the Flex versus other calibration processes. So I think the range of, a number of months is definitely fair. I don't know if we have specific guidance yet. My guess is the range will be on the order of 6 to 12 months if nothing kind of has happened. I do recommend running calibration if there's some kind of crash for any reason. It's worth just rerunning a calibration. Or again, as John mentioned, if you attach a new pipette, that's a good time to run a calibration as well.
Yeah, and on the volumetric calibration, right now, our expectation is an annual volumetric calibration. We actually offer a kind of proprietary service that you can talk to your account manager about that would give you a discount on kind of future pipettes based on that volumetric calibration, so that you don't have to pay many thousands of dollars for a third-party service to come in and do that calibration. We do have some partners that can provide that, but we really recommend basically swapping out your pipettes for new ones. The affordability as a whole makes it easy. Having backups is something that we really strongly recommend, just so that you avoid any downtime. But I would say that the short answer is annually is really what we'd recommend. Obviously, other labs have their own policies in place. I've heard of people needing to calibrate it, once every quarter, right? So we can accommodate whatever's needed, but annually is what we would generally recommend. Any comments, Nick?
Nope, right there with you. Each pipette ships with its own specifications from its own testing, so you can be really confident that out of the box it'll work quite well. But I think annually is definitely fair.
And Fran, I think that answered the first question, albeit in a fairly long-winded way, just given the complexity of it. But what was the follow-on question to that? Or did we already answer it?
So I think this is really what happens if there's an error. So what happens if one barrel on an 8-well multi-channel is out of spec versus its neighbors?
Go for it, Nick.
Yeah, I think at that point it probably is time to speak with our team about what might be possibly causing that. Sometimes the solution's easy. Sometimes it's something as simple as it's causing suction on the bottom of a plate or something like that. So, we'll work with you to resolve that. It's not a protocol related issue or kind of a simple issue like that. If it is something that we can isolate as being the root of the pipette, then I know that we can work with you to get a replacement out.
Great, thank you so much. Okay, so this is another great question. Would it be possible to change the number of samples in a protocol on the screen to make the robot even more flexible?
Great question. So I'll start off and then let Nick chime in. As of right now, that is not possible. The on-deck display in its current form is used for onboarding and user-guided setup, calibration, uploading of protocols, adjustment of settings. You don't currently have the capability to actively adjust sample count, well count, pipette movement, for example, on the screen. That's really just built directly into the protocol that you've uploaded, and it's running that protocol. In the future, we do have an expectation that there will be a significantly enhanced level of flexibility that you referenced, where you can actively adjust things on the deck, or sorry, on the on-deck display. Right now, it's not possible. Will be possible in the future, though. Don't have an exact timeline on that. So bear with us as we build that out, but that is definitely something that's a part of our roadmap.
Great, thank you. Okay, so here's a question from Jessica, which I might take myself, if that's okay. So
Sure.
Have application notes been written for the use of biotage phi tips for purifications on the Flex, as was the case for the OT2? And so we have not published any application notes for phi tips on the Flex, but that work is in progress. So I can connect you with the scientist who's working on it at the moment. Thanks, Jessica. Okay, we're still rolling. So there are just a couple more open questions. So, but we do have plenty of time. So if anyone has any additional questions, keep them coming in the Q&A box. Okay, so here's a good question. Another question from Anon. Have you tested or predict that the machine will be compatible to run library prep for 10x RNA-seq or similar?
Yeah, so specifically, I don't know of any work that we've done internally to test the 10x protocol. We have run at least parts of the 10x protocol on the OT2, and I do think that we plan to do some testing in-house. That said, I think I would recommend you for some protocol development services from our team. We can chat about developing and working on a protocol together and work through the optimization period once we send the protocol over to you, if that's something that you'd be interested in. But at this time, I don't have any internal testing that we've done on the Flex with the 10x protocol.
Super. Okay. I think that we just have one more. And this is, a great question from Agnes. To facilitate sterile workflow once the HEPA module is available, can the gripper be used to remove culture plate lids? It would be great to be able to load culture plates from the incubator for the cherry picking feature.
Yeah,
Pretty
I can maybe take
Oh,
that
yeah,
one.
yeah, go for
So the gripper is compatible with a wide array of plates. Within the API, you would notice that there are offsets to accommodate different types of plates. We can fine tune those knobs to fit whatever labware that you have. Basically, as long as it's a kind of a standard rigid labware, we can pick it up and drop it with the gripper. I think there was a bit in there about taking it off an incubator and onto the deck. I just want to call out that the capacity of the gripper spatially can only reach these kind of accessory areas on the deck. And we do have accessory slots that will be able to hold plates that aren't being actively pipetted to, but we can't actually reach outside of the robot with our gripper to access, let's say, a third-party incubator. We have had successful integrations, again, speaking on our open source nature, with third-party arms to move from an external instrument onto the OT2 deck, and I'm sure we'll build that out in different applications for the Flex as well. So if you have a specific application, we can definitely work with you to develop a solution leveraging a third-party system to get those plates from an incubator onto the deck.
Okay, super. Thanks, Nick. One more question just came in. Is the robot easy to set up yourself like the OT2?
Yeah, I could start. So generally speaking, the kind of messaging that we have is that, there's some flexibility with this, right? I mean, it's in the name kind of, right? The idea is that this is a more complicated and a more sophisticated system than the OT2. Therefore, we recommend using our expert services via our field application sciences team to do on-site installation. And we are strongly, strongly focused on making sure that customers are getting on-site installation and on-site setup and protocol development, just because it provides you with a much, much higher level of guaranteed success, essentially. If you are extremely technically savvy, if you are very, very knowledgeable on the OT2, if you have, automation engineers on hand, there is a world in which this can be self-installed. We really tend to try to recommend against it just for the user experience. But the short answer is yes, if you are absolutely set on doing this yourself, it is possible, but we really would feel and think users would feel much more comfortable having our team at least come in, do the setup, do the installation, and then work with you from there.
Great,
So,
thanks.
sorry, real short. Is it as easy to set up as the OT2? I think it's a little bit more sophisticated is kind of the immediate answer to that, which is why I would recommend using our on-site services.
Perfect. Okay, we still one more question just popped in as well. So I'm just going to keep going. We do have potentially a whole another 19 minutes to fill, so we've got plenty of time to answer questions if there are still questions. So there is another question. Are there plans to apply for UL certification for the Flex? My understanding is that UL certification is kind of a third-party safety and performance certification.
Yeah, so the OT2, I believe, and I will follow up on this, so take this with a grain of salt. I believe the OT2 is both CE and UL marked. That would lead me to believe that our electrical engineering roadmap covers that for the flex. I do not believe that is currently the case, but I would be shocked to hear that we are not planning to pursue it. So if that's a major blocker to actually getting the system in, please feel free to let us know. The general understanding that I have of these systems via our electrical engineering team is that we already are, the system has all of the capabilities in place to be UL certified. It is quite literally just getting the actual certification that is the next step. So we build this with those types of certifications in mind. But I do not believe we have it right now. We will follow up on this though. Nick, if you have any more info.
Nothing else beyond what John said, so I'm going to stick to that.
Cool. Thanks, Fran.
Okay, one more coming in as well from Chris. Are there plans to add nucleic acid concentration measurement options for the Flex? So I think that is saying, are we planning on integrating plate readers or nano drops or similar types of instruments? And Chris, if I'm getting that wrong, feel free to keep typing, but that's what I'm understanding the question to be.
Yeah. So we have seen third-party plate readers again integrated on the deck. If that's something that you'd be interested in, I'd also like to plug that we're constantly developing and testing new modules on our system. I can't say that we have something in the pipeline right now for a plate reader, but I wouldn't be surprised if that's in development in the somewhat near future. So stay tuned for that. But again, specifically, if you'd like to follow up about a specific integration that you're interested in, I'd be more than happy to speak with you about that after the call.
Yeah, I mean, as a products-based company, our team is constantly thinking about what our roadmap looks like now, 6 months from now, a year from now, 5 years from now, and beyond. So I think that there's a lot of opportunity there for us to develop things that you're requesting. In the immediate roadmap, to Nick's point, there is nothing kind of directly there. But being a smaller, kind of more agile team, and small is subjective, but being a more agile team, we can very easily and do very quickly kind of adjust based on what the market is looking for and what our users need. And so, that's just kind of an overarching statement about Opentrons as a business and our ability to do things that can help our users. So nothing immediately in the pipeline right now, but that's not to say that that won't change down the road.
Okay, and that concludes all of the questions. I'm just going to give everyone 10 more seconds just in case anyone has a burning question that they wanted to answer that they didn't get the chance to ask yet. But I think we're done. So over to you, John.
Okay. All right, we'll wrap it up. So thank you so much to everyone who joined us today for this live demo webinar. Before we go, one final reminder that if you're interested in the Flex software and seeing what's going on in the touchscreen display, we will be taking a deeper dive into this next week in a webinar. You can find details on it on our website under About Events and Webinars. And I am sure we'll be sending out an email or two, if not already. Thank you again, and have an excellent day, folks.
Thanks.